Faraway galaxies are one of my favorite things to photograph and edit, and I usually use my large telescopes for that purpose. But there is one galaxy that requires a completely different approach. Our own galaxy, the Milky Way. Milky Way photography is the gateway drug to astrophotography for so many of us because you can really just get started by pointing your cell phone at the sky when you're in a dark sky location. As simple as basic Milky Way photography is, I feel like it is the one that requires the most planning when you want to take it to the next level. The one thing that absolutely cannot be replaced is a dark sky location. It is more critical for Milky Way photography than for anything else. But for everything else, we have tools to make our lives a lot easier. And the most important tool, apart from the camera, in the arsenal of an astro landscape photographer is a star tracker. Today, I'm going to show you how I use the MoveShootMove Nomad star tracker to take a Milky Way photo that I've been planning for a really long time. My name is Luca and you're watching the Space Koala. MoveShootMove is a well-known name in the astro landscape photography world, but still relatively niche in broader astrophotography circles, mainly because they focus on a very specific type of gear. The name MoveShootMove might sound odd, but it comes from their original tracker design. That early model could connect to your camera via a hot shoe cable and detect when a photo was being taken and alternate between moving and shooting, ideal for time lapses. However, when they released the upgraded Nomad tracker, they dropped that feature. As it turns out, about 90% of the users were only ever using the device as a star tracker, and so they focused on perfecting that functionality instead. The product changed, but the company name stuck. I, for one, had and actually still have the original MoveShootMove. I bought it several years ago and have used it to capture many images since then. I like to bring it with me when I travel to a dark sky location, and while my telescope is shooting the sky, I set up the little star tracker and shoot the sky also with that. But first of all, why do we even need a star tracker? Well, of course, it's because as the Earth rotates, if we shoot the stars for a long period of time, they become stripes, and that is sometimes a desirable effect, like when you want to take a star trail image. These are actually the easiest ones to do because you just literally have to leave your camera on a tripod and take a really long exposure, or take a couple of them and then overlay them. However, if you want to avoid that feature, if you want to avoid the effect of the stars trailing and pulling streaks across your images because you'd like to get a sharp picture of the Milky Way, you have two options. Either you go with really short exposures, or you somehow counteract the rotation of the Earth. The first option is definitely doable. You just have to make sure that you keep your exposures short enough. How short is short enough? That depends on a number of factors, but the most important one is the focal length of your lens. The shorter your focal length, the more forgiving it will be, and the longer you'll be able to shoot. And when you're under really low light conditions, like under the stars, we want to keep our exposures as long as possible. Just to give you an idea, let's see how long we can actually shoot for without any sort of a star tracker or special devices. The simplest way to estimate this is with something called the rule of 500. It is a basic guideline that says if you divide 500 by your focal length in millimeters, it'll tell you roughly how many seconds you can expose for. If you want to calculate this more precisely, there are a bunch of calculators. I'll put a link below to one of these calculators. It's free and you can just plug in the properties of your camera and then it will give you a much more accurate exposure time. So yes, this is absolutely doable, and using this technique, you can take your Milky Way images to the next level. However, you'll always be limited by this exposure time, and that makes it really difficult to bring out those darker regions of the sky, like the dustlings of the Milky Way. They will just remain very noisy. If you do landscape astrophotography for a while, you will definitely get to a point where you want to start tracking the sky, and this is when star trackers come into play. A star tracker is essentially a very simple device. All it is a single motor that completes a full rotation in 24 hours, just like planet Earth, but it rotates in the opposite direction, and this cancels out the effect of Earth's rotation completely. The only real skill involved is knowing in which direction this axis of rotation has to be oriented. That axis needs to be aligned parallel to the Earth's rotation axis. There are many tools available to help with this process, which we refer to as polar alignment. These tools vary both in difficulty and in precision, and as a result, so does the outcome. What you need to know is the longer you want to expose and the longer your focal length, the more precise you need to be in your alignment. In order to point your star tracker at the celestial pole, you'll need to mount it on a structure. This could be a polar alignment wedge like this one, which is the easiest tool to work with, but it could also be a tilt and pan head for your tripod, or even just a simple ball head. This device goes between your tripod and your star tracker, and it is what you will use to set up the initial position of the tracker. The starting position is simple. You need to point your star tracker generally towards the north, and then the tilt, which is the altitude, should be equal to 90 minus your latitude. Just keep in mind, I'm in the northern hemisphere, so if you are in the southern hemisphere, just substitute south every time I say north. So if you're at this stage, you have what we call a rough polar alignment. To get it more accurate, you'll need to wait until it gets dark. From that point on, you'll need to use some sort of a tool to improve the precision. In the evening, I'll be driving up to the nearby mountains. There's a location I've been planning to do a Milky Way shoot at for a while. My idea is that the Milky Way will sit nicely on top of the mountains, forming like an arc or a bridge between them. So I'll see you from there in the dark. Okay, so I'm up here and it's really cold. I've roughly polar aligned my setup. I've also placed my camera on top of it. Please note that on top of the actual MoveShootMove, there is an additional ball head that allows me to point my camera in any direction I want while still keeping the MoveShootMove aligned towards north. To polar align it more accurately, you have a number of options. In the northern hemisphere, we're in a very privileged position because we have a pole star, Polaris, which is very close to the actual celestial pole. So for short focal length Milky Way photos, it's usually enough to just point directly at Polaris and your tracking will be precise enough. If you want to shoot longer exposures or use a telephoto lens, you'll need to be more precise. The Nomad offers a few options for doing that. The easiest one is a laser pointer that you can screw directly here into the Nomad. It shines straight through parallel to the rotation axis, and so you know it is perfectly aligned, and you can just point it directly either at Polaris or slightly off if you know where the actual celestial pole is. Unfortunately, I cannot demonstrate this because these types of lasers are very illegal in my country of residence, in Switzerland. But as far as I know, they're allowed in most other countries, and they make polar alignment extremely easy. Without the laser, there are other options, and I think they're especially helpful for our southern hemisphere friends. There's a phone adapter you can attach directly to the tracker. It uses the gyroscope in your phone and helps you polar align just about as accurately as you could with the laser. Before you start, make sure to reset the gyroscope or sensors on your phone. You can do that just by holding it up and moving it around in a figure 8 motion. After that, insert your phone into the holder and point it at the sky. You can use any sky app you prefer. I personally use Sky Safari because I'm used to it, and at this point I'll just center the celestial pole in the app. Here I'm using the MoveShootMove Wedge, which I find really simple to work with. You might recognize it from some of my other videos, it is the same wedge that I use to polar align my C-Star smart telescopes as well. Now, if we want to get more accurate than this, we'll need to use the polar scope. You can order a polar scope for the Nomad, and I really think it's worth the investment if you're planning to take precise long exposure Milky Way shots or other astrophotography. It is simply the most accurate way to polar align the mount. So the polar scope goes directly onto the tracker, onto this adapter, and it is really quite snug, like it is not moving at all, which is a really nice design. It ensures the polar scope is perfectly aligned with the Nomad's rotation axis. Even here we have two options. This easy one is just to center Polaris in the view, but of course that's not 100% accurate. If you want to be precise, you can use a polar alignment app. The one I use is called Polar Scope Align. It looks like this. There's a free version and a paid version. I'm using the free one, and it shows you exactly where Polaris is in relation to the true celestial pole from your location at the current time. The app uses GPS to calculate everything, so it knows your precise coordinates and time. All you have to do is make sure that in the polar scope, which shows the same little reticle pattern as the app, you place Polaris at the correct point in the small circle. That circle is about 36 arc minutes away from the true celestial pole, which is the offset between the pole and Polaris. This might actually sound more complicated than it really is, so let me just do that quickly. So I can see that Polaris is sitting in this direction right now. So I'm going to align the view accordingly. Okay, now that we're precisely aligned, it is time to actually start shooting the Milky Way. If you have a way to remotely control your camera, that can be really helpful. Every time you touch the camera, you introduce vibrations, which can cause trailing stars or motion blur on your images. So if you don't have a remote control, you can use an intervalometer, a built-in interval timer in your camera, or even just set a delay of a few seconds after pressing the shutter. I'm using a Leica SL2-S. It is a full frame camera with 24 megapixels, and my lens is an f2.8 with a focal length of 24 millimeters. That focal length means I won't be able to fit the entire arc of the Milky Way in one shot, so I'll do a mosaic instead, capture it in sections, and then stitch the images together later on the computer. As for the foreground, the mountains and the lake here, of course, if I take 1 minute exposures, those are going to move because the camera is tracking the sky. It's moving along with the stars. So when you use a star tracker, you have to shoot the foreground separately with the tracker off. If you can, shoot the foreground before astronomical night or when there's the moon still up to have a little bit of natural light on the surroundings, because if you're in a truly dark sky location, there will be nothing illuminating the ground. Okay, so I didn't record the whole thing, but that actually went quite quickly. I did 6 panels and I did 3 1-minute exposures of each of the panels of the Milky Way. Ideally, if you're in a true dark sky location, you don't need a ton of time to shoot the Milky Way. If you're in a nice place, it should show up as a fairly bright object in your image already at like 1 minute. But before we wrap up, let me show you one more fun thing you can do with these star trackers. I mentioned earlier that if you leave your camera on a tripod without tracking, you'll get star trails, and that can be a fun effect. But if you're a bit impatient like I am, there's a trick to get those nice star trails twice as fast. Since I'm polar aligned to the north celestial pole, and this tracker is rotating to follow the sky from east to west, if I flip the switch on the Nomad to the southern hemisphere setting, it will rotate in the wrong direction. That means the stars will appear to move twice as fast. and I'll get nice long star trails in half the time. So I'm gonna do that now and let the camera shoot just for a few minutes to show you what that looks like. Of course, before you go home, don't forget to take your dark frames. This video is not the right time to go into details about why that is needed, but they are definitely needed for these non-cooled mirrorless or DSLR cameras. So just take a couple of them by covering the front lens and taking some long exposures, the same length as the shots that you took of the Milky Way, and then you can feed that as a dark frame in your software of choice. Okay, I'm now back home. Let me share the photos I got. This is the final result. I ended up using just 4 out of the 6 skies panels, and so I kind of wish I had done more than just 3 minutes of each panel to get more detail. But overall, the image is exactly the composition and atmosphere that I was going for, so I am quite happy with it. Now, let me show you the individual pictures I took. As you can see, even zoomed into 100%, the stars are round, there's no trailing, and the tracker worked extremely well. And finally, here's the fun 2x speed star trail image. This is just a 5-minute shot to give you an idea, but if you're gonna do this, of course, you'll need much longer than a single 5-minute image to make it look good. So what do we think about the Nomad? Like I said, I've been a happy user of MoveShootMove trackers for, I think, about 5 years now, and I believe they're a very solid option, especially for the price point that they're at. In terms of build quality, there's a significant upgrade from the original tracker to the new Nomad, especially in terms of accessories. The polar scope is much easier to use and more stable once installed. If you can use the laser, that is supposed to be super easy to use as well, as you can just twist it in directly. As for drawbacks, the illumination tool that they give you with the polar scope is kind of useless in my opinion. It's this tiny piece of fluorescent plastic that you put around the scope and it's supposed to illuminate it. As you may have seen in the video, I just use my red headlamp pointed downwards so that the light enters through the side of the opening of the polar scope, and that illuminates the reticle nicely. Otherwise, of course, your experience will also vary depending on how precisely you align the mount, what camera you put on, and how sturdy your tripod is. I used a nice one, which I'll link below, but you can use any solid tripod you have. So is it worth it? The Nomad itself costs $229, but keep in mind that you'll need a few extra accessories. You're gonna need either a ball head or a wedge or something else to polar align with, and then for precise polar alignment, you'll need to pick between the phone adapter, the laser, or the polar scope. I would say just skip the other tools and go for the polar scope directly. You will also need a second ball head to aim your camera at your target. So while the tracker costs $229, you will spend somewhere between $300 and $350 to get the full package. Still, it's one of the best deals you can find for a star tracker. If you decide to get it, you will be able to get a discount by using my discount code SpaceKoala. I'll put this in the description as well. Now, if you wanted something significantly more versatile than this tracker, you're looking at spending over $1,000 for an advanced go-to star tracker such as the Benro Polaris. So within its price range, the Nomad is likely the best bang for buck, at least among the devices that I've had the chance to try. I hope you enjoyed this video, and I hope it inspires you to get out under some dark skies and shoot your own Milky Way photos with or without a tracker. Nights are getting scary short here in the Northern Hemisphere, but Milky Way season is here, and there's nothing more beautiful than the glow of the Milky Way core. So thank you so much for watching, and I wish you clear skies.